We're following the reciprocal functions handout. The general form of a reciprocal function is y equals k over x, where k is some constant other than 0. The simplest reciprocal function is when the constant equals 1, and that can be written as y equals x to the power of negative 1 using index notation. As we've done with linear and quadratic and cubic relationships, let's look at a table of values and see if we can work out how to recognize a reciprocal function. If we look at it closely, we'll realize that there is not a constant first, second or third difference, and neither are the values in ratio to one another, in constant ratio to one another, which would indicate that it's an exponential function. What we do see, however, is that if we multiply x and y together for each pair of values, we get a constant. Now, I actually found a mistake on the sheet. The word ratio should actually be product, so the sentence should read the product of x and y gives the value of k, because k is a constant, and the equation is given in this case by y equals 24 over x, because the constant is k equals 24. In general, reciprocal functions represent inverse relationships, which means as one variable increases, the other one decreases in proportion. So the key features: there's a horizontal asymptote along the line y equals 0, and there's a vertical asymptote along the line x equals 0. We can also see that when x is positive, y is positive, and when x is negative, y is negative. It's also true that if x is large, y must be small. Again, that's the idea of an inverse relationship. As one variable goes up, the other goes down in proportion. So similarly, if x is small, y must be large. Okay, so here's a simple graph. This graph is actually of y equals 1 over x. And you can see there's an asymptote along the x-axis and an asymptote along the y-axis, and the graph is only in the first and third quadrants. But what if k is negative? In that case, the graph is reflected about the x-axis. You can try a few values to see that that's true, and we get this graph. A couple of other things to note. The first graph was just y equals k over x. The second is now y equals negative k over x. It's true that the point shown always has the coordinates k, k, and on the other side in the third quadrant, negative k, and that observation makes it easy to determine k from a graph. A couple of worded applications. Suppose A is inversely proportional to B. So inversely proportional are words that tell us it's a reciprocal relationship. We've got two variables A and B. So that means that A is proportional to the inverse of B. A is proportional to 1 over B. That little sign reads proportional to. If we introduce a constant k, then we have an equation. And we can rearrange that to give k equals A times B. In this question we're given two values. If A equals 16 and B equals 5, we can just substitute those values and calculate k equals 80. So therefore our equation is A equals 80 over B. We're asked to evaluate the equation for when B equals 10, so we substitute B equals 10 and we get a value of A equals 8. In general, what happens to A if B is doubled? Well, remember, as one goes up, the other goes down in proportion. So if B is doubled, then A must be halved. And if A is doubled, then B must be halved. Second question, we have a force of F newtons that exists between two bodies or masses And we're told that this varies inversely with the square of the distance d centimetres between them. Two bodies 5 centimetres apart produce a force of 1 Newton. So we can use that information to set up a reciprocal relationship and work out the equation. So first of all, we start with interpreting the words. Force F is proportional to the inverse of the distance squared. That's 1 over d squared. Can you remember what we do to turn this into an equation? We introduce the constant k. And now we can rearrange that to give k equals fd squared. So if f equals 1 and d equals 5, k is 1 times 5 squared, which is 25. Therefore, the equation is f equals 25 over d squared. And if d is 8, substitute d equals 8. So f equals 25 over 64, or 0.39 newtons. Part B. Now we're told the force, and we can use our equation to work out how far apart the two bodies are. Since we know that f equals 25 over d squared, if f equals 4, we can rearrange that equation to give d squared equals 25 divided by 4. So we take the square root of that and we get 2.5 centimetres. That's a nice application in physics. I hope you found this presentation useful.